that fraud is involved in some degree with about 30% of the financial transactions that occur. With 9 billion people, let's say you thought maybe you could get to some fairly large percentage of that kind of population. They can't hack the URLs because the URLs are the value. That is the account. Okay.
Like, what could be your suggestions for the new builders who are building on a blockchain ecosystem? What should they consider before jumping into the project? Hey, hi everyone. So, welcome to my YouTube channel. Today we have a very special day. We have a very special guest, Paul. Hey, hi Paul. How are you?
I'm fine. How are you?
I'm doing great. I hope you are doing great.
Doing great.
Amazing. So, guys, Paul is a legend and OG of blockchain space. It's our pleasure. So we got able to host Paul on our YouTube channel. So he's a CEO of IDD Labs, previously called DeFi Dev. So over to you, Paul, for your introduction first.
Well, I don't know what to say. I have been in the blockchain space for a long time. I did some of the earliest work on tokenization, things like NFTs and other coins that run on top of other protocols. Back then, it was all Bitcoin. So and that work I did alongside Vitalik. I won't claim that I'm as anywhere near as prolific or impactful as Vitalik, but
Mm.
it was a fun time to get to know people before the rest of the world knew they existed. That was really great, and I continued in the crypto space. I went full time into crypto in 2013, and I ran the Texas Bitcoin Conference. That was the first crypto or Bitcoin conference in Texas,
Mhm.
and probably the first in the middle of the U.S. The very first conference was
Mhm.
the famous San Jose conference in 2013, and the next big Bitcoin conference that was done was just a week before us in Florida with the North America Bitcoin conference. Um,
Amazing.
and it was a great time to be involved in crypto. You
Mhm.
could walk up and meet and talk to all the great names, and yeah, that Bitcoin conference got me involved into a development project. I was recruited to architect and build a data centric layer one protocol called Factum, and Factum had a great deal of success. Uh, but I would say is I've got a lot of insights into what makes a crypto product work or project work, and what are some of the dangers or traps for projects
Right.
earned in the hardest way, hard knock way. Um, the I will say that it has been incredibly fun and incredibly rewarding to work in a crypto project. And currently, what I've done is I've taken what we learned in Factum,
Mhm.
we rebuilt and rebranded Factum into Accumulate, and
Wow.
that's probably what we're talking about today.
Yes, yes, Paul. So I have one curious question. Like, you are being there from so long time, Bitcoin, and what keep you to be more trustworthy about the Bitcoin or blockchain technology and to keep it carry forward? Because it's hard at that time to trust the technology and to be a early adopter, right? So what was your key, thought process towards that?
Well, I I I go a long ways back. I mean, you can tell I'm an older guy, and from the very earliest days, I've been very skeptical of large. organizations and things like governments, but it's not just governments. It's also established religious orders, or it can be large companies, or it can be supposedly nonprofit groups. All these things that become fairly big, that involve a lot of people,
Right.
and there's a potential to earn a lot of money to be
Mm.
within those organizations, or at least money and power. Then
Ah,
those things are very untrustworthy.
yeah.
We could go through history. I mean, we could argue about
Mm.
today's politics, but it's not really hard to go back in the past and point to big failures of the Roman Empire, for instance. Nobody has any emotional attachment to that. The Roman Empire did all kinds of bad things. If you go look at Chinese dynasties, you can argue that those early dynasties did all kinds of bad things. Um, I know that India
Yeah.
is pretty perfect and they
Mm.
never did anything bad in their history. But if we scratched
Yes.
long enough and hard enough, we might be able to find a few things that are
Mhm.
universally accepted as, oops, we made a big mistake as a large group of people. This is constant.
Mm.
Bitcoin was the first thing I've ever run into where, no matter how hard large groups of people can try to commercialize it or hoard it or
Mm.
control it, it is fundamentally distributed. It's fundamentally permissionless. Everyone involved gets to be
Right.
involved without
Yeah.
asking
Yeah.
anybody's permission. I mean, we're all breathing air. Everybody else gets free access
Correct.
to air. And Bitcoin is like that. It's
Mm.
an infrastructure. It's almost as important to air as air for economies and businesses to be able to transact, and it's free. I mean, it's free in terms of you can use it. By the way, you don't just get air for free. Actually, you have to use muscles to pull it in. You have to use muscles to pull it out.
True.
If those muscles fail, then you die. With Bitcoin, it's kind of the same way. It's free access, but there is an effort that has to be involved, and it's all very well defined. And so I figured this out looking at Bitcoin in the early years,
Mm.
and I thought, this is very, very novel. I don't know if it can continue to succeed,
Mm.
but I could not find the only point of failure that I saw in Bitcoin was that ultimately it would not be able to have the transaction rate necessary to support the world.
Okay. Yeah. Mm.
But my early work in tokenization suggested
Mm.
that we would be able to tokenize Bitcoin onto other platforms
Mm.
and be able to trade it, and it will always be able to resolve to the ledger that the Bitcoin and the miners are running. That's the key,
Right.
you know, that everything is accountable. And so, I mean, I'll just go crazy if you get me on this topic, because there's a few puzzle pieces, but once you grasp those puzzle pieces,
Mhm.
there's just no reason to doubt.
Amazing, amazing, amazing. So I think you had very deeper into that, and you got the root, like the power of decentralization, and you got it, the trust, the power of decentralization, and that Bitcoin came. So it's amazing. Now, so I would love to talk more on the IID Labs or Cumulates.
Mhm.
It's your one of the ventures. So what exactly you guys are doing there, and what's great stuff you are building? Can you please show some lights on that?
Okay, well, we're doing something very hard,
Okay.
and we have a very small team,
Hmm.
and we are building this platform that could be a blockchain integration with the internet as a entire ecosystem. Basically,
Okay.
we designed Bitcoin so that it could be a internet protocol, just like HTTPS
Yeah.
or
Hmm.
HTTP. You any browser could be a blockchain explorer, not that you have to have let how should I put it? The the internet would be able to access any one of a number of nodes that anybody
Mhm.
wants to put up, and they would all represent the same data with the same sort of URLs that you use on the internet,
Hmm.
with basically properties that any group or individual can control. When you get a domain name, you
Hmm.
can build your stuff under your domain name.
Right.
Nobody gets to mess with it unless you allow it.
Amazing.
Okay.
Hmm.
Now,
So I think,
websites get hacked,
uh,
but we are going to protect that with the blockchain. Go ahead.
yeah. So when you explain this term, so I'm little familiar with the IPFS concept, right? So
Hmm.
when you can host your own URL and it gets spread out on your IPFS nodes, so that's actually those things fascinates me to enter into the blockchain, and that was like, damn man, I can host my website in a decentralized way, and it's serving at each node, whatever those who are parting consuming that particular node in the network. So I think similar manner you are trying to create that ecosystem. But nowadays it's not purely up and running there, what I feel, because let's say
It-
the example of Explorer or some, it's hosted on our normal clouds only, right? So we are consuming from there itself. But so okay, so I would love to know more on like how exactly you are doing, or let's say what stage you achieved in your product as of now.
Well, the product is up and running, and I would say that Accumulate is in some of the early days where we need to build more infrastructure and we need to build more, get more adoption, and build more nodes.
Mhm.
The way the protocol is designed is as more parties get involved and more parties join, they bring more capacity.
Mhm.
And so, unlike Ethereum and unlike most protocols that you will study,
Mhm.
as more people join, the resources to run the protocol become strained.
Correct.
That's why Ethereum fees go high.
Correct.
That's why Bitcoin fees
Go.
are occasionally high.
Right.
More people means more stress on the network.
Correct.
We're designed so that everyone bringing architecture to the network builds its computational power and builds its capacity. And we basically have no theoretical limit on transactions. We
Okay.
don't have any theoretical limit on what kinds of operations can be performed on the protocol.
Mhm.
Uh, what I would say right now is we would like to integrate with existing protocols, manage the security, for example, on Ethereum or other protocols, so that
Mhm.
you can go to one place and manage your security without requiring transactions and paying gas on Ethereum,
Okay.
and be able to send tokens to people safely without bridge, third party risks that you have with bridging and
Mhm.
that sort of
Yeah.
thing. So and we would like to create um, all this infrastructure, and it comes from taking the security of the blockchain
Mhm.
and putting the security as transactions in the blockchain. In other words, what we do is we create key books,
Okay.
and those and accounts specify a key book for their security. And so that means, since there's a level of indirection there, that
Mhm.
means that on the blockchain, on the layer one, you can change your keys, but you don't have to move your asset. Your asset stays in the same place it was,
Okay.
but you're able to rotate your keys.
Mhm.
Or if you decide to move to multisig, you can add somebody to your key book,
Yeah.
and now the two of you have to sign, perhaps,
Correct.
for that asset to move, but the asset stays where it was. And it gets even better. Let's say you build a whole infrastructure underneath this ID,
Mhm.
because the other thing about Accumulate is we build everything on top of domains or identities. So
Mhm.
just like the internet,
Mhm.
you have you have the option of creating mycompany.com,
Right.
and you can build some whole
Domain.
infrastructure under mycompany.com.
Right.
You can create here mycompany.acme. We
Mhm.
use Acme for our token. We use it for our first level domain right
Okay.
now. We will create other top level domains, but
Hmm.
today,
Today is different.
uh,
Yeah.
because we have to figure out how to design so that we respect, say, .com.
Hmm.
At some point, it may be that anyone who has a domain .com in the real world would be able to create and control a .com on the blockchain, and then their .coms can interact.
Interact.
And
See.
so let's say you underneath your mycompany.acme,
Hmm.
suppose on the blockchain, suppose you build a bunch of infrastructure.
Okay.
Now in the real world, you can sell that company as mycompany.com. I can sell it to someone else, but the website doesn't change. It just
Hmm.
who has the authority to
Oh,
manage it, right?
the owner will change simply. The ownership you are transferring from one individual to the another individual.
Right.
So,
With our
hmm.
key books, you get to change the ownership
Hmm.
on the key book, and suddenly you've sold a whole infrastructure you've built
Hmm.
on the blockchain to another party.
Amazing.
And that also means that a NFT,
Hmm.
NFTs we know on Bitcoin are very constrained. The ordinals and the runes, they're very constrained. There's not much you can do there. Certainly not much you can do that's dynamic.
Correct.
With let's say there's a rune out there that's a big bear, on Bitcoin. You can That might be a picture of a big bear. That's all it'll ever be.
Hmm.
On a big bear on Accumulate could have tokens. It could issue tokens and manage the issuance and the um, burning of those tokens to represent, I don't know, feeding bears in the wild,
Okay.
right,
Hmm.
around the world. There might be a panda section under Big Bear
Okay.
dot Acme, right? It's about your love of pandas. All that infrastructure underneath, Big Bear slash Panda,
Right.
or Big Bear slash China slash Panda,
Hmm.
whatever,
Yeah.
right? All that infrastructure is under that Big Bear, and if the investors come in, you can bring them in. If somebody is the president, they have signature authority inside of Big
Hmm.
Bear to do various things. When that president retires, you take his keys out and you bring in somebody else.
That's
And so the idea with Accumulate is we can model the real world all on a blockchain.
okay.
And
Amazing.
so
Hmm.
we can build just amazing businesses on the blockchain and integrate in with other blockchains like Cardano and Bitcoin and Ethereum, whatever.
Okay. So, is it fair to say at Cumulate you have a flexibility or functionality to create DeFi's, real world asset, and all those great stuff, NFT marketplace, right? So all these whatever currently in blockchain mostly mainnet works, all type of that DApp and DeFi stuff we can create at Cumulate, right?
Absolutely. Hmm.
Amazing. So it's like a mainnet sort of thing, or layer one or layer zero one, right? As it
Yeah,
yeah.
we don't fit in the layer model.
Okay.
Layer zeros have largely referred to things like Polkadot and Cardano and whatnot, where
Yeah.
they claim they are creating, or Cosmos,
Cause
they're creating a base on which other blockchains can
can
live,
build. Yes.
and so
Yes. Uh-huh.
you could have a layer one
Uh,
that sits on, call it, my blockchain project, right? My my blockchain project can be a layer one that sits on top of Polkadot, a
mm,
layer zero, and then my big blockchain project could have tokenization,
mm,
so that you have protocols layer twos that run on that layer one, and that layer one runs on the layer zero. Accumulate kind of can play any of these roles, and they can play all these roles at the same time for the same project. It can act like a layer zero, it can act like a layer two, it can it could act like a layer one. It's like the internet. What layer do we call the internet? I mean, the internet in some ways is a layer one.
Right.
right?
Hmm.
Because ICANN's over there issuing domains and whatnot.
Right.
But you don't have to have a domain to be on the internet. That's all about HTTP protocol. You if you just have an IP address against the hard level,
Hmm.
then you can access servers. You don't need
You don't
domain
need
names,
domain, correct.
right? So the internet even acts like this. It acts
Hmm.
like it behaves on different levels, and so that's kind of the way Accumulate is.
Amazing, amazing. Sounds good, sounds good. Yeah, we should. I love
It
to
looks like I'm hurting your head. Am I
know.
hurting your head?
No, not at all. Just I'm trying to understand how it is designed and how it is different than the other whatever chain we have, right? The concept. Just trying
Hmm.
to understand that way. So we
Well,
can
that
uh,
if you get under the covers, it really gets interesting. For one thing, we're a network of networks, and
network of
so
networks. Okay. Mm-hmm.
we there is routing based off the URLs in our system, but the URLs are not what you expect because on the internet a domain name URL
Mm-hmm.
is just something that represents an IP address, and if you go and edit the URL it can now represent a different IP address. And so one of the big hacks on the internet is to get control of somebody's URL and redirect it to a scam site that looks
Yeah.
just like your website. Now they can hack your customers. I mean, that's happened.
That.
That happened.
Yeah.
Well, with us, the URLs are literally the data. We
Mm.
literally use that like a Bitcoin address is a Bitcoin address. A URL in our system is that address.
Address.
It's not the security, it's the
Mm.
address of the content. Now, how do I then manage that security? Well, I manage that because that address is tied to a keybook. And so that keybook is what's controlling that address.
Mm.
Now, that means that if you're going to attack something in Accumulate, you attack the security, you attack the keybook.
Keybook.
That's what you do. So there's attacks. There's always attacks on the internet.
Right.
But if I give you a URL,
Mm.
you know that URL is the pointer to the content that I'm representing to you.
Right.
You can't get between the URL and the content. That's supported by the blockchain. That's
Okay.
immutable. You can't change
Okay.
that.
Right, right. There is no middle layer or middleware sort of thing which can get triggered multiple. It's like that content is
Right,
directly bind with my address or URL. There is
right,
no multiple layers which can someone get plug in and just they can tweak at different place. They cannot
right. Or redirect the
redirect. Yeah,
yeah,
they
yeah.
cannot
That's not
manipulate the
possible.
content. Correct, correct. So
Yeah.
on the same line, I just recalled one questions. So you have been here from a long time, and in ecosystem there are multiple hacks we have observed, right? So what's your observation, and what are the vulnerabilities we have in the blockchain which is leading to these major hacks? What's your view on this?
Well, these hacks are always on infrastructure.
Right.
So, for instance, this 1.5 billion dollar, hack that occurred to Bybit. I mean, I'm sure that's what's coming to mind. Uh, they attacked the address, the wallet, and so the user who was thinking they were moving coins from cold storage to warm storage, or the other way around. I don't remember which way. They thought the destination. They understood what the destination was,
Hmm.
but they hacked the wallet, the infrastructure that the Bybit was using, and when that transaction went through, it was didn't go where they expected it to go. It went to the hacker's
Hackers
address,
account.
and they got $1.5 billion worth of ether.
Right.
You know,
That's yeah.
so if you're going to attack infrastructure like that,
Hmm.
I would say for Accumulate, there's a great deal of risk
Hmm.
for all blockchains, because you're using some UI, and it's very hard to be sure that the UI you're looking at is connected to the right engine behind it.
Mm,
Now,
right.
with our architecture, we do have some advantages
Mm,
because a lot of the blockchain steps are not in the infrastructure, they're actually in the blockchain.
block.
For instance, when you create a multi-sig on our architecture,
Mm-hmm.
let's say I have to sign something and you have to sign something.
Mm,
Well, we look at through the Explorer
okay.
at the artifacts that are in the blockchain. Okay. And so, number one,
Mm,
they can't hack the URLs because the URLs are the value. That is the account. Okay. Then when I go to sign, create a signature and submit it to the blockchain. And then you sign something and you submit it to the blockchain.
mm,
So the actual construction of the multi-sig transaction
mm,
is orchestrated on the blockchain, not orchestrated in infrastructure. So
right.
where a normal blockchain might attack the infrastructure and take and present to you your wallet something to sign that is incorrect,
Mm,
and same with me on my end. So we both think we're signing a particular transaction, but we're really signing a different transaction,
mm,
and it gets submitted. Well, in our system, I'm not talking to you and using infrastructure to decide what to sign. I'm actually using the blockchain to find the thing that I am signing, and then I'm submitting it to the blockchain, and you're submitting it to the blockchain, and the blockchain is putting it together. So there's no place in the infrastructure where there is a thing collecting the signatures that can
get
fake people out.
correct.
You
So
know, you're actually interacting with the blockchain. Go ahead.
yeah, yeah. So here we are not keeping a room to expose the keys and that can get muted at any place. It's like
Mhm.
direct blockchain construction, and the keys is absolutely getting tracked in the blockchain itself. You don't need to track it somewhere else.
Well,
Yeah,
keep in mind, everybody manages their keys on in their wallet,
in wallet.
and this hack with Bybit was not about getting access to the keys.
Hmm.
The hack with Bybit was to get the parties to sign a transaction that was not the right
Oh.
transaction.
Hmm. Right.
But in our
The
situation,
malicious transaction. They used to sign the malicious transaction on the check.
right, and in our system, we submit the transaction to the blockchain.
Hmm.
Then we use the blockchain to decide to sign the transaction.
Oh. Hmm.
So there's no place for the attacker to create a missing, because if he creates a bad transaction,
Right.
it'll be in the wrong place in the blockchain.
Correct. Correct.
It won't be in the right place in the blockchain.
Correct. Yeah. True. So true. Yep. So I think this was a great explanation, and I think accumulation tree is a great thing over here. I would,
Hmm.
everyone should use that, in a great way. Yeah.
Now, another interesting thing about our blockchain, if
Mm-hmm.
you look at most tokenization on Ethereum or any of these other platforms,
Uh-huh.
they're using a smart contract to create the tokens,
Correct.
right?
Hmm.
And so there is kind of an intermediate layer there.
Hmm.
When we create a token issuance account in the protocol, the token is actually handled through all the same infrastructure that the native token is handled.
Okay.
In other words, accumulate the Acme token that you used, our native token,
Hmm.
it comes from a particular account
Okay.
in the protocol. If you create your own token, like the Bebop token, because
Hmm.
you like Bebop,
No.
right? That has an issuance account, but in the protocol, that Bebop token will be handled exactly the same way through exactly the same code
Hmm.
as the native token.
Hmm.
So these tokens are very standardized.
Hmm.
They use the same mechanisms, and thus it is difficult, if not impossible, to create tokens that behave in some sort of unexpected way. Now, in some sense, that's tough because you would say, "Oh, I would like my token to have these different functionalities."
Hmm.
Well, we have mechanisms for doing that in our protocol, but the way you do that is you create validators and and servers,
Hmm.
either through a service so that you don't actually deploy validators, or you create your own validators
Okay.
to add more functionality on top of your token. That means that people that are issuing tokens on Accumulate, and let's say they become worth billions of dollars, there's a lot of tokens that are worth billions of dollars that run on top of Ethereum,
Hmm.
right? Um, then you're going to bring your servers to Accumulate to create that functionality that you want, and you're not going to pay gas fees. You're just going to pay for the computation because you're providing it. And two, it'll be, not only is it cheaper for you,
Hmm.
but you can have enormous functionality behind your tokens because
Oh,
you're not limited to what you can afford in a smart contract.
correct.
Like I could list off all kinds of functionality I would like to have on an Ethereum token,
Hmm.
but there's no way anybody would pay the gas for that functionality.
Correct. So whenever you will add more function, you are making your smart contract more expensive. As simple. And
Right,
if your customers don't want to spend that much cost for the normal simple transfer functionality or just any withdraw functionality, why they will uh, pay for your other smart contract functionality? Completely makes sense.
right.
So this
Go ahead.
leads to one question in my mind. So do we have here like the same standards like ERC 20 or 721 like that, or do we have a different structure of tokenomics or creating tokens here in Accumulate? Like how the thing
Well,
works? Yeah.
as we build infrastructure for Accumulate, basically add functionality to Accumulate, we add more servers, and then we will emulate all of the functionalities of ERC 20s and 720, and all the different standards.
Mm-hmm.
We'll do that. Most of that hasn't been done yet.
Ah,
Right now, ERC 20 is pretty much just what we've already implemented, which is a standard token, and you can trade it, and it has certain qualities like how many decimal place, what's its resolution and things like that.
right.
Okay, we've got that. That's built in.
Mm.
But when we start doing real estate tokens and things like
Yeah.
that, all these
Right.
other standards, then we need to bring more infrastructure to play.
Okay.
And we have plans for doing that. We just
Mm.
have to get there.
Okay. Amazing. Amazing. Okay, so yeah, that was like it's a great thing what you are doing here. Amazing. So the next question I have, like, what could be your suggestions for the new builders who are building on a blockchain ecosystem? What should they consider before jumping into the project? Because what I observe, most of the people are running behind the hype. Let's say crypto is booming or some meme coin
Mhm.
is booming. So many people are just creating a lot of projects without any proper use cases behind it. So what would be your suggestion for the new builders or those who want to try to build a business on top of blockchain?
Well, it's very, very hard
Hmm.
to criticize, from a financial and opportunity point of view. It's very hard to criticize a meme coin,
Right.
because a meme coin is just fancy, some marketing, and it does nothing. So you don't have anything to do on the technical side. You just issue it. So I would say, you know, if you if you're a famous actor or a politician, or
Right.
maybe a model,
Hmm.
okay, consider a meme coin. It's just free money. I'm being a bit sarcastic. if you're talking about trying to change the world,
Mm,
like create something that addresses, I don't know, whatever your thing is, save the whales.
mm,
You want more windmills, you want less windmills, pick your issue, whatever your issue is. Or maybe you're trying to do some um,
mm,
distributed implementation
mm,
of various financial services that are possible, in the financial system, or
mm,
securities, or whatever else. Then you have to just ask yourself how successful you can be with current transaction limitations on blockchains. And I know there are a lot of people that believe that, for instance, protocols like Solana or whatever are
mm,
the cat's meow. They have all the transaction volume
mm,
capability you need, up to 70,000 transactions per second, all that. That all sounds wonderful, but with 9 billion people, let's say you thought maybe you could get to um, some fairly large percentage of that kind of population. Understand that it's not a transaction per person. It's how many connections do 9 billion people have to
mm.
other people and other companies. 70,000 transactions would effectively mean nobody can communicate with anybody. That 70,000 transactions per second just isn't enough.
Yeah.
So all these, so you've got to consider, what is your use case? Is is it Do you have at least 5 years of runway
Mm,
with the technology that exists today? Because after 3 or 4 years, you can see where we're going. I believe in 5, 10 years, uh, 700,000 transactions per second will be common
correct.
on some blockchains.
True.
Okay, so I believe that we'll scale. You have to look at each of these protocols to decide whether that's the protocol that can scale. There are very few that have a path today that will get them to 700,000 transactions per second. Very few have that path
Mm,
yet.
great.
However, that doesn't mean they can't upgrade their infrastructure. That doesn't mean they can't create
Mm,
new tools and new ways to get there. And I believe they will. And I don't believe Bitcoin will. I believe
mm,
Bitcoin's path to scaling is not to put functionality into Bitcoin. It's in its ability to connect to infrastructure that can provide that functionality.
functionality.
And if I look at the Bitcoin volume on any exchange, on CoinGecko or anybody else, you can see billions and billions of dollars of Bitcoin are shifting between people. They're not doing that on chain.
Right.
There's not enough room, but it is happening. And all these exchanges are far more auditable because the Bitcoin that they hold can be seen on the Explorer.
Mm,
So Binance cannot claim to have, um, let's say, 5 million Bitcoin if there's not an address out there associated with
mm,
Binance with
minus.
5 million Bitcoin in it.
Correct.
That's huge because, in contrast, banks and financial institutions and payment rails in the traditional world, they're not auditable at all.
Right.
You can't see if they have the balances they want. This is why you can have a company like Enron. Back in the days, old people will remember Enron. It was a huge financial scam, but nobody could tell.
Mm,
Look at the gold in Fort Knox.
right.
Do we know how much gold's in Fort Knox? Nobody knows because
Minus.
the gold it's not auditable.
Right.
Not to disparage any country,
Mm,
but lots of countries claim to have certain amounts of gold.
good.
but there's no gold blockchain to look and see if they've got an address with that much gold.
Correct.
No, that doesn't exist.
True, true.
So,
It's nothing like that.
and it can't exist. And you can't even, once you're over a certain level of gold, it can't be audited because nobody can go and look at every brick of gold
Hmm.
and look at every serial number.
Right.
And if even if they did, then you don't have any idea if any of those have been swapped out with a tungsten with the gold wrapping,
Yep.
because it'll all weigh the same. And the only way to tell if that gold exists is to melt it all down.
Yeah.
Nobody's going to melt down all their gold.
True.
So gold can't be audited. Bitcoin can. So buy your Bitcoin because ultimately we're going to back currencies with something. Because
Right.
I think, of course, I was convinced
Hmm.
decades ago that trusting the government for the value of your dollar or your whatever your currency is, trusting the central bank was foolish
True.
because they can't be audited, you can't be controlled, you have no idea what they're doing.
Hmm.
Only way to create some kind of stability and trust
Hmm.
in the currency is to do it in a distributed autonomous fashion like Bitcoin. And right now Bitcoin is the one that's the most secure, and you leveraging second layers, it can serve the world.
Right.
And so I believe in that. But after you've got the currency dealt with,
Hmm.
the next thing to look at are all the applications that involve data. So
Right.
it's one thing to say how much gold you have.
Hmm.
The next question is, when I bought those vitamins and it said it came from this organic source,
Hmm.
did it?
Right.
Or what about your credit score, your debts? Are those real?
Who knows?
Probably not. None of these systems are auditable.
Right.
We're trusting who? We're trusting people that in the next breath you
Huh.
turn on some news and they'll be telling you you can't trust these people, but they're the people you're trusting.
Correct.
The
Like.
only way the only way to create processes we trust is to manage data on the blockchain, and that is our goal. That's our target. We're not targeting smart contracts, we're
Hmm.
targeting data.
Data.
How do I manage the data? How do I manage the website that I'm looking at to make sure it's the
Hmm.
website I'm looking at? How do I manage the transaction I'm signing to make sure that's the right transaction? How, there's all this, and you lose money by bit
Yeah.
when you're signing data, which is a transaction. Not at that point it's not money. It's a data transaction between multiple parties to sign to get something done. How do you trust that data if there's no blockchain?
Correct. 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 So, like here, data plays a very crucial role, and that's what you are trying to
Yes,
do to bind everything with the proper data and make sure that data is secure and it's bind properly with the blockchain ecosystem, so no one can alter it or mute it. Amazing.
exactly.
Right.
Exactly. And then the question is authorities. See, unlike a lot of blockchain people, I believe everything is centralized.
Hmm.
But by centralized I mean if you own a house and you own a car and you have a bed and you make yourself meals, you're doing that in a centralized way. You
Yeah.
are a person that owns a car and a house, and you are making your meals for you. That's centralized. But
Correct.
you live in a city. You don't own the city. You only own your little part.
Part.
And your neighbor owns his little part, and his neighbor owns another little part.
Hmm.
Everybody has to be able to own the part of the data that is their data, and they have to be able to create cryptographic proof of their data when they exchange it with other data.
Right.
And so ultimately, we need this massive blockchain that's ensuring, even if it's only temporarily,
Hmm.
ensuring that data is correct from the origin. It is from the origin, and it got to you without being modified by somebody.
Yeah, that's important. Yep.
And so originally the architecture of Accumulate was designed to secure the electric grid
Oh,
in the United States.
okay.
So the electric grid in the United States is massively insecure.
Mm,
Everybody knows that. Everybody's been talking about it forever.
mm,
One of the tropes is you could, if you had the right knowledge,
mm.
$12 could take down all the power systems on the East Coast,
Okay.
right? All you have to do is inject messages that transformers need power, and and then the power plants overdrive and blow out all those transformers, or someplace doesn't need power, so you
Mm,
bring down all the transformers in the systems, and then they can't come back up because they were starved for power. You can't When you cut power out of the electric grid,
mm.
you lose all of the state of all of the systems.
Correct.
And one of the things that was said over and over, you can look it up. When Texas a couple of years ago had the deep freeze, and everything got really, really cold, and all of our power plants nearly all went down at the same time,
Okay.
they claimed that if we lost all of our power, if that happened across the system, it would take months to bring it back up,
Mm.
because so much of the electric grid is exists in live systems, and they kind of back themselves up. They can bootstrap themselves up, but if you take them all down,
Mm.
you can't get it back up.
Exactly. Okay.
And so we built this system where we could exchange,
Mm.
using the blockchain, the keys
Mm.
between systems, and then we could create signable transactions without changing the protocols or anything, but just signable transactions, so that when a transformer station is saying it needs more power
Mm.
to the power plant, that message, came from the transformer
Oh,
stations, and it was really talking to
yes.
the power plant.
Mm.
And you can't have the overhead of looking at the blockchain, but you
Mm.
can use the blockchain to ensure everybody has the right signatures.
Right.
And then there's because we're a network of networks, the
Mm.
idea was to create these networks of networks that all summarized into a hash for the entire system,
Wow.
a proof, and then you create a Merkle proof to that hash, and you send it to other people. And the total data transfers between everybody is like bytes.
Bytes. Yeah.
It's not even K, not even thousands of bytes,
Ah.
bytes. And those bytes enable the creation of proofs
Mm.
that allow them to pass along security information. And better yet, the security is all local. So it's not like you're creating some great big database of security.
Yeah.
You distributing the security, you're distributing the ability to create proofs, and you're distributing the ability to check those proofs. And now suddenly, you know, you could conceivably register a bogus transformer station.
Ah.
That could conceivably happen, but it would also be obvious that that happened,
Mm.
you know, because it wouldn't be able to interact properly with the real network.
Right.
Anyway,
So, but anyway, the way you started it, it was great. Like the concept, the the traditional method, what you relate with the or the problem you try to solve with the cumulate, and to managing the protocol, the managing the key, and to make sure that the source of that data is the genuine and the original one, to verify that. So that's a great thing. Yeah, amazing.
right. Now let me explain accumulate. I should have done this in the very beginning.
Yeah, yeah, sure.
Why are we named accumulate? Well,
Yeah.
we're named accumulate from this concept of a validator accumulator
Uh-huh.
architecture. So what we think is that there will be thousands, maybe millions of validators. A
Mhm.
validator could be you for your own data, because you're signing that data. You're saying that it's valid to you. You could be lying, but nonetheless, you're a validator. And there could be blockchain validators that are collecting hashes and whatnot and creating a cryptographic proof of the state of, say, a subset of things. Well, the accumulator is that it takes a lot of validators and it accumulates those cryptographic proofs.
Hmm.
And then that accumulator itself can issue a proof of its state, just one hash, right, at that moment in time. And it can go to, it can be part of some other set of validators that are now accumulating it again. So it looks like a tree. You have the one main accumulator that's creating the state of the entire electric grid. You have accumulators in various locations that are collecting the validated information from various transformers,
Right.
and then they may connect to a power station that has its own accumulator that's collecting data from up there. And all of these different parts of the network are sending their cryptographic proofs that are accumulated here, there, and yon, and those are sending proofs that are accumulated. And so, like a tree, you've got
Right.
a a proof of the entire network that you're collecting, say, every few seconds, right?
Right.
And that bleeds all the way down to a transformer you got way out in the
Hmm.
country servicing a farm,
Right.
okay?
Yeah.
Every few seconds. So you just have this ability now, if something in the system has collected some piece of information that it needs to communicate to something else, a simple signature. And over there, when they get that, they go, I'm not sure about that signature, but it has a ID to it.
Hmm.
So the ID can be validated,
Right.
and then I can validate that it was properly signed,
Hmm.
and I can now accept that data.
Right.
So
This is how
anyway,
it's accumulate. Yeah.
so it's not about accumulating necessarily the token. It's about accumulating cryptographic proof of
Oof.
everything in our lives. We
Hmm.
should be able to validate. When you see a video, you should be able to validate that that came from an actual camera.
Right.
Yeah. If you
Correct.
can't validate that it came from an actual camera, then can you trust it in this day of AI?
Hmm. No.
The AI is going to get so good that this video could be completely auto generated. It will get that good.
Yeah.
It's not there yet, but it will get it it will get there.
Yes.
And we'll need to have signed proof that this was recorded,
Recorded
what
or
day it was
generated,
recorded.
yeah, or tempered or edited or whatnot. Multiple things.
Absolutely. And this could eliminate, there are estimates that in financial transactions that fraud is involved in some degree
Hmm.
with about 30% of the financial transactions that occur,
Hmm.
to some degree,
Something.
some element of fraud.
Hmm.
And what all of that all that fraud exists on the fact that nobody can validate this stuff.
Hmm.
And let me say, this is just all, nobody can prove it. One of my big arguments, every time I hear somebody say, we know that election was valid,
Hmm.
I say, how? Did you how did you validate? What, there's so much data. How
Right.
did you validate
Gotta
all
be
that
that.
data?
Right.
If you can't validate it, you can't say that. I mean, I'm not saying that I think every election is fraudulent,
Good.
but I can
But
say when you say it's not fraudulent,
okay. But how it is validated also, like how you say
yeah,
it's
how did you
purely,
validate it?
purely
Yeah,
genuine. Like how you are
what magic
validating it.
spell?
So,
Usually that means I liked what the election did.
hmm.
Well, I know you liked what the election did. That's not the question.
The question is how this data is validated. How you
How
make
was
sure
the
that
data validated?
how this counting is validated? Who is validating that? By the way,
Yeah.
that's the question.
Yeah, who carried that box of ballots in? You sure none of them slipped out? I don't know. You know?
Yeah. So ultimately, these all are guys saying the things. So on the same line, I literally believe, and I have portrayed these one proper proposals as well in my this channel as well for elections. I literally believe this election should happen in a decentralized way and on a blockchain based way. It's
Well,
must to be.
I absolutely believe that
Yeah,
all electronic voting should be done on open source hardware, on open source software,
right.
and it all needs to be hash validated.
Hash value.
And this is completely possible.
Yeah,
Completely
it
possible.
is completely possible. Yeah.
I don't want voting on the blockchain, but I want everything involved in voting, all the processes, to be on the blockchain. I should be able to know who walked in to a vote counting center with the box of ballots
Hmm.
at what time and how many ballots he had, and whatever. I
Hmm.
want everything about the process to be validatable.
Yeah. So at any certain time, anyone can validate what exactly happened under the process. So they can
Right.
trust the process at least, and they can say, yeah,
Yes.
it's like it's a valid process, and yeah, they elected in a proper way. It's very important.
If you validate all the processes,
Yeah.
then I'll still claim there's probably some fraud. There's always some step that you can't get on the blockchain, but I'm going to be a lot closer to saying, yeah, that's a fair election.
That
That election was clean.
clean. Yeah.
But you know, but without even any validation,
Hmm.
I don't think you can make these statements.
Right. 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 So like a very great talk. It's loving to talk you more and more, but we have a time constraint. I mean, and we are
Sure.
already past 55 minutes. So I think I would take a last question. So what's your simple advice for youngsters like me who are very new to the ecosystem and who are trying to build or learn something from the blockchain, and what you feel, is this blockchain, is it really a futuristic tech, and do we keep our believing in the tech? So what's your thought on that? Because there are some people used to say, is blockchain dead now, AI boom is came, so there are a lot of hacks is happening, and lots sort of things. So what's your thought on that point as well?
Well, I mean, I believe you need the blockchain with AI because AI has history, and the only way you'll be able to prove the history of things and the
Mm,
facts over time, the sequence of things, is with a blockchain, because the AIs are going to be able to create what we take as proofs. We
mm,
don't, they're not really proofs, but what we take as proofs of things, they'll be able to create all that. You need five people to say this guy, um, you know, ran the mile at
mm,
this speed, and I've got a video. That that's proof today. It's not proof in the age of AI. We'll easily be able to create the video. We'll easily be able to create the five guys who said so. And
mm,
then after 10 years, when those guys are dead, or
mm,
at least they're too old to remember what happened, then what value is any of this if I can just create pasts,
mm,
create statements when somebody says something on TV, in an interview, with anchors who say yes, he was there.
mm,
Okay, but that's not that's just hearsay. At some point, you don't know if they've got their kid kidnapped with a gun to their head. They're going to say anything.
mm,
So there's, I mean, I hate to be vicious about it, but the point is there's a lot of viciousness in the world, and
mm,
when there's billions of dollars involved, what do we do? I mean, people can get blackmailed with
mm.
sex tapes, but what if you just generate a sex tape? You can still blackmail somebody
Right.
because they didn't do it, but who's going to believe them?
Believe that. Right. Correct.
Yeah, and so we've got to have the blockchain to create proof of the past. We
Mm,
need that. And so I think blockchain plus AI is going to be incredibly powerful. Oh, by the way,
mm,
blockchain needs AI too, because we have a lot of protocols out there that are proof of stake. And the
mm,
security is the idea, if they misbehave, they're going to get slashed. Therefore, they are obligated to behave well. because they could lose effectively a bond they put up to
Mm.
participate in the protocol. Okay. But how do we know they misbehaved? A lot of times the blockchain has all kinds of ways to create a proof of misbehavior,
Yeah.
but people are limited. We're not looking at all that stuff. I mean, the Bybit guys couldn't even do the steps they could have done to ensure they were signing the right transaction. Okay,
Correct.
because people have limited time, they can and they don't necessarily understand what they're looking at, and do they understand a cryptographic proof? We need AI to do that.
Mm. Right. So what I feel, we need both the technology hand in hand, and there is future
Yes,
for both. It's not like one is important and one is not important. Both are important, and there is future is both. So here, guys, we got this thing from Paul. So we need to understand both the technologies together, and we have to build it for a greater and amazing future together.
amazing future. Yes,
Yes. So, Paul, thank you so much for giving your precious time, and we almost cross our 1 hour, and it would feel like it was a very great talk. And I would love to host you again for multiple such great sessions together. I hope, right?
no problem.
Yeah,
Okay.
sure.